Hello. Humanoid robots have long fascinated us in films, sometimes as villains, sometimes as helpful companions. But now, science fiction is becoming reality. Real humanoid robots are being built in labs worldwide. These machines are designed to help in hospitals explore dangerous places and even learn to walk and think. Building one is a blend of art and engineering, transforming raw materials into something that can move and sense the world. In this video, we'll reveal how these robots are conceived, designed, and brought to life. Let's dive in. Every robot starts with a purpose. What problem will it solve? Its job shapes everything. A gentle companion for the elderly needs a friendly design, while a rescue robot must be strong and tough. Designers sketch out ideas, deciding on height, features, and personality. Then, they move to powerful software, creating a detailed 3D model of the robot. This digital twin lets them test how parts fit and move together. Engineers use simulations to make the robot walk, balance, and interact virtually. If something fails, it's fixed in the simulation, saving time and money. Only after perfecting the digital design do they move to building the real thing. It's creativity and precision, all before a single part is made. That's how a robot goes from idea to blueprint. With the design ready, it's time to choose materials. Robots need to be strong but light, so engineers use aluminium, titanium, and carbon fiber, materials found in race cars and aircraft. Each part is crafted using CNC machines, which carve metal with computer-guided precision. For complex shapes, 3D printers build parts layer by layer, even using metal powders fused by lasers. This allows for lightweight, intricate structures impossible with traditional methods. The goal: maximum strength, minimum weight. Every component is made to fit perfectly, ready for assembly. Modern manufacturing turns digital designs into real, functional parts. The robot's body takes shape, piece by piece. Now the robot needs muscles, actuators. Specialized electric motors and gears power each joint, from shoulders to ankles. Engineers balance strength and weight so the robot can move efficiently. Wires run through the body, delivering power and commands from the central computer. The battery, usually in the torso, must be light yet powerful enough for hours of operation. Battery tech is a major challenge. Robots need more energy to work longer. Every movement, from a simple step to a complex gesture, relies on this intricate system. Without precise actuators and wiring, the robot can't move at all. It's a delicate dance of engineering. This is how robots come to life. To interact with the world, robots need senses. Cameras serve as eyes, giving depth perception for navigation and object handling. Depth sensors and lasers help map the environment in 3D, even in the dark. Microphones let robots hear and respond to voices. An inertial measurement unit, IMU, keeps the robot balanced, sensing motion and orientation. Touch sensors in hands and feet allow delicate gripping and help maintain balance. These sensors work together, letting the robot see, hear, and feel. With them, robots can pick up fragile objects or walk across tricky surfaces. Sensing is what turns a machine into a responsive, interactive being. It's the foundation of real-world robotics. All those sensors feed data to the robot's brain, a powerful onboard computer. Artificial intelligence processes images, sounds, and touch, building a real-time map of the world. The AI recognizes objects, understands speech, and plans actions. It decides how to move, avoid obstacles, and complete tasks. Modern robots learn from experience, improving with every attempt. Through reinforcement learning, they adapt and get better at their jobs. This ability to learn and make decisions is what makes robots truly intelligent. The brain turns raw data into action. That's what separates a robot from a simple machine. Finally, it's time to assemble everything. Technicians carefully piece together the chassis, limbs, sensors, and computers. Wires are routed, actuators installed, and the outer shell attached. Every connection is checked for precision. Software is loaded, and the robot is calibrated. Each joint and sensor tested. Then comes the big moment. The robot stands and takes its first step. It may wobble, but it's a triumph of engineering and creativity. This is the result of thousands of hours of work. A machine, built in our image, comes to life. And that's the magic of humanoid robots.